Okay, Pure 2, Chapter 1, Algebraic Methods. So Dr. Frost obviously makes the best slides, which we're going to be using. So what we're going to do to start with is we're going to be simplifying algebraic fractions. So if you are happy to go ahead, off you go. If not, I'm going to go through them quickly and then we have some questions for you to do. So for the first one, we should have noticed straight away this is a difference of two squares. So what I'm going to do is I know that x squared minus 1 is the same as x minus 1, x plus 1. On my denominator, I can clearly see we have a factor of x. So I'm going to factorise out x, and then I have x plus 1. Now, clearly, we can see there is a common factor in the numerator and the denominator. So I'm going to cancel those out. And I'm going to be left with x minus 1 over x. So again, this is just GCSE recap. Question 2, we're going to factorise the numerator. Two numbers that multiply to give you 2 and add to give you 3. It's x plus 2 and x plus 1. On the denominator, we have x plus 1. So again, we have a common factor on the numerator and the denominator. We can cancel them. And we're going to be left with x plus 2. For the third question. Now, here you can either factorise the numerator in your head. So you know you're going to have a 2x and an x. Two numbers that multiply to give you 12. We've got 3 and 4, 6 and a 2. But I know with 3 and 4, if I double 4, I get 8, and then I plus 3, I can get 11. So I know this is plus 4, this is plus 3. Now, obviously, I know I'm a maths teacher, and for me, it works in my head, and it just comes natural. If I was to type this into the calculator, and I have my A, B, and C, I'd get two answers. I would get x equals minus 4 and x equals minus 3 over 2. So I know I can put those back into the brackets. If x equals minus 4, I know x plus 4. And then if x equals minus 3 over 2, I know that that's x plus 3 over 2. And how do we get a fraction, rid of a fraction within that bracket? We multiply everything in that bracket by 2, which would then give us 2x plus 3 over 2 times 2, which we just know is 3. Okay, you could also do the AC method if you want, and I can discuss that with you, not right now, but another time. Two numbers that multiply to give you 20 and add to give you 9, plus 4 and plus 5. We can clearly see we can cancel our plus 4s, x plus 4s. So we're left with 2x plus 3 over x plus 5. Then for the last one, on the numerator, we've got two square numbers, difference of two squares. So we've got 2 minus x, 2 plus x, all over. And then two numbers that multiply to give me minus 8, but plus 2 is going to be plus 4 and minus 2. Now, if we have a look here, I've got x minus 2, 2 minus x, 2 plus x, and an x plus 4. So what I can do is I can rearrange this. The 2 minus x on my numerator, I can actually change. If I take out a factor of negative 1, I then get negative 2 plus x, x plus 2 over x plus 4, and then I've got x minus 2. Now, we know that minus 2 plus x and x minus 2, they are the same thing. So now we can cancel them. And then we're going to be left with minus x plus 2 all over x plus 4. So we could again write that as minus x minus 2 over x plus 4. And then we have fully simplified all of these fractions. So, we're having a look at our terminology here, okay? Does anybody know what any of this terminology is? If you think about what's going on here, what are they? We have 11 divided by 4, okay? So we have a few things going on. So this 11 is the thing that we're dividing by, okay? This is actually called a dividend. I think that's how you say it, but I'm not entirely sure, okay? Then this is the thing that we're dividing by. So this is called the divisor. Then the number 2 is what we call quotient. And then number 3 is called our remainder. And as you can see here, it says rem, okay? So we have a remainder. So you will hear me say the words remainder and quotient quite often in the next few slides. So what we're going to do is imagine, okay, before you saw this, you were given this question. All over x plus 5. And it said simplify this, okay? First of all, I'm not even sure how we're going to begin to factorize this cubic, okay? So what we do is we're going to do algebraic long division. So our favourite few words, and we're going to repeat after me in a second. IMSB, okay? I'm a silly Billy. So I'm a silly Billy stands for into, multiply, subtract, bring down. And this is how it's going to work. So we always start with this term here. We say how many x's go into 6x cubed. So we're basically saying x multiplied by what gives us 6x cubed. And that is in fact x squared. So 6x squared. Okay, so that's step 1. This is our into. So how many x's go into 6x cubed? It's 6x squared. Now our second step, multiply. We're now going to multiply this term by both of these. So 6x squared times x, 6x cubed, 6x squared times 5, plus 30x squared. And when we write them under here, we have to make sure that we write them corresponding. Because now what we're going to do is subtract. So I'm going to subtract 6x cubed minus 6x cubed gives us 0. This is how you know you're doing it right, if that first term cancels, because it should. Then 28x squared minus 30x squared is minus 2x squared. And then the last step is bring down. So we're going to bring down this next term here so we know what's happening. Minus 7x. Okay, we're going to start again with I'm a silly Billy. We're now going to say into, but what we're going to say is how many x's go into minus 2x squared. And that is minus 2x. So then, step 2, what are we going to do? We're going to multiply. So we're going to do minus 2x multiplied by x, minus 2x squared. Again, you can see these are going to cancel. So we're on the right track. Then we're going to do minus 2x multiplied by 5, minus 10x. Our next part of our I'm a silly Billy is subtract. We're going to take these away. Minus 2x squared minus 2x squared is minus 2x squared plus 2x squared, which cancels. Minus 7x minus 10x is minus 7 plus 10, which is positive 3x. Then our last step, bring down. So we're going to bring down that 15. So we should always have 2 terms here. Next step, back to step 1 into how many x's go into 3x, and that is 3. We then multiply, so 3 times x is 3x, 3 times 5 is 15. And then our last one, positive 15, is we subtract. 3x minus 3x is 0, 15 minus 15 is 0. So what we have done is we've fully factorised this first term, not fully factorised, but we know that 6x cubed plus 28x squared minus 7x plus 15 can also be written as x plus 5 multiplied by 6x squared minus 2x plus 3. What we could now do if we wanted was now factorise the 6x squared minus 2x plus 3. So what I would like you to try and do is I would like you to try and do this. I'm going to give you a minute head start to see how far you can get. Give it a little go and I'll explain it in a second. Okay, so everyone should have at least been able to do this first step into how many x's go into 3x cubed. It is in fact 3x squared. We now have multiply, so we're going to multiply 3x squared by each of the terms of the divisor. So 3x squared times x, 3x cubed, 3x squared times minus 1, minus 3x squared. We're now going to subtract. Now you know you're correct if the first term in your subtraction cancels. 3x cubed minus 3x cubed is 0. I've then got 0 minus 3x squared, that's plus 3x squared. So be careful with those negatives. After we subtract, we bring down minus 2x. Ready to start again. Into, how many x's go into 3x squared? And it is in fact 3x. I'm now going to multiply. 3x times x is 3x squared. 3x times minus 1 is minus 3x. Now I'm going to subtract. Again, you know you're right if this first term cancels. Minus 2x minus 3x is minus 2 plus 3, which is just x. Then after we've subtracted, what do? We bring down plus 4. Back to the beginning, into. So how many x's go into x? Lucky for us, it's plus 1. Oh, I've used a different colour there. Wait there, let's get back to this colour coordination. Now we're going to multiply. 1 times x is x. 1 times minus 1 is minus 1. Then going to subtract. X minus x, 0, so you know you've done it right. 4 minus 1 is 5. So I wonder, what is different with this one compared to the one before? Why is this one different? Have we done it wrong? Or is this allowed? What is this actually saying? So we do have a remainder of 5. So that means that if we were to write this as a division, no, actually, I'll save that. Right, it just means that we have our quotient, 3x squared. So our quotient equals 3x squared plus 3x plus 1, and our remainder equals 5. Okay, well done for those great theories. So I want you to test your understanding. I want you to give this a go completely on your own before I will go through this. If you feel really confident, once you've done this, send me the answer. I will double check, and then you can go straight on to the questions on the next slide. So if you feel really comfortable with this, you can then do the challenge on slide 11. So give this a go first. I'll go through it in a second. So we're going to write down the most important thing we need to know. I'm a silly Billy. Then how many x's go into 2x cubed? It is 2x squared. Multiply, so we're going to get 2x cubed minus 8x squared. Subtract, these are going to cancel. Minus minus is a plus, so minus 5 plus 8 plus 3x squared. Bring down minus 16x into 3x. Okay, multiply. We're going to have 3x squared minus 12x. Subtract. First two terms are going to subtract. We know we're right. Minus 16 minus minus is minus 16 plus 12, which is minus 4x. Bring down plus 10 into minus 4. Multiply. Minus 4x plus 16. Subtract. Minus 4 minus 4 minus minus 4. 10 minus 16. Minus 6. So please make sure that you write your quotient equals 2x squared plus 3x minus 4, and your remainder equals minus 6. Any questions? So what I'm going to do now is go through this again with colours. So I say to myself, the first term here, okay, now this first term, it's the term with the x in, so here, x. How many x's go into 2x cubed? So I'm saying x multiplied by what gives me 2x cubed? And that is 2x squared. 2x squared times x gives me 2x cubed. So that's what I do. Okay? Or I can do 2x cubed divided by x. That gives me 2x squared. So I start with this term and this term, and this is how I get this answer. Now, 2x squared, I multiply this by x to give me 2x cubed, and then I multiply 2x squared by minus 4 to give me minus 8x squared. Now, once I've done that, I subtract these two terms and these two terms. So 2x cubed minus 2x cubed is 0. So I'll just put a dash. Minus 5x squared minus 8x squared is 3x squared. Positive. This is how I get my 3x squared here. I then bring down the next term, ready, minus 16x. So then, once we've got this ready, I start the whole process again. I say, how many x's go into 3x squared? This is the same as 3x squared divided by x. The answer is 3x. So I put the 3x up here. I then multiply 3x by x to get 3x squared, and I multiply 3x by negative 4 to get negative 12x. I now subtract both of these from each other. So 3x squared minus 3x squared is 0. Minus 16x minus 12x is minus 4x. I then bring down the last term, plus 10. I now start the sequence again into how many x's go into minus 4x? The answer is minus 4. I then multiply minus 4 times x gives me minus 4x. Minus 4 times minus 4 gives me positive 16. I now subtract. Minus 4 minus 4x cancels. 10 minus 16 is minus 6. My quotient is up here, which is 2x squared plus 3x minus 4, and my remainder is here, which is minus 6. So we have to divide 8x cubed minus 1, wait there a second, 8x cubed minus 1 by 2x minus 1. Now what you'll notice here is you're going to start writing it like this. This is incorrect, okay? Because when we have our x cubes, what else should go in place here? We have 0x squareds, 0x, and then we have our minus 1. So I say how many 2x's go into 8x cubed, and that is 4x squared. I can now, remember because I'm a silly Billy, so we've done the into. Now it's multiply. 4x squared multiplied by 2x is 8x cubed. 4x squared multiplied by minus 1 is minus 4x squared. I can now subtract. 8x cubed minus 8x cubed is 0. 0x squared minus 4x squared is positive x squared. I can now bring down plus 0x. Start at the beginning, into. How many 2x's go into 4x squared? The answer is 2x. 2x times 2x is 4x squared. 2x times minus 1 is negative 2x. I can now subtract. 4x squared minus 4x squared is 0. 0 minus 2x is positive 2x. Now bring down minus 1. 2x multiplied by what is 2x? It's 1. We now multiply. I'm going to get 2x times 1 is 2x. 1 times minus 1, minus 1. Now I'm going to subtract. So I'm going to get 2x minus 2x is 0. Minus 1 minus minus 1 is also 0. So our quotient is in fact 4x squared plus 2x plus 1. So we have the factor theorem, okay? Now, we can see that x minus 2 is a factor of this if, and what we're going to do is we're going to substitute in what happens when x is 2. So if I substitute in what happens when x is 2, I get 2 cubed plus 2 squared minus 4 lots of 2 minus 4. 2 cubed is 8. Plus 2 squared, which is 4, minus 8 minus 4. This is going to equal 0. So, it stands that if we want to know, if we're saying x minus p is a factor, then the function of p equals 0, okay? So if it's a factor, when we substitute in, it equals 0. So here are some examples. Part 1 says, show that x minus 2 is a factor. So that means we're going to show that f of 2 equals 0, okay? If x minus 2 is a factor, then f of 2 will equal 0. So as we've just seen then, we're going to have 2 cubed plus 2 squared minus 4 lots of 2 minus 4 equals 0. This is true. Therefore, x minus 2 is a factor. So, sometimes we get a question where it says fully factorise this cubic. Now, we have to factorise it. The quickest way to factorise this is to find a factor. Okay, we're going to do polynomial division, which is what we've been doing. And then we can fully factorise it. So, we're going to try. So we're going to see first, using the factor theorem, if we want to see if x minus 1 is a factor, we're going to put in 1 into our function. So we're going to have 2 lots of 1 plus 1 minus 18 lots of 1 minus 9. So I'm going to get 2 plus 1 minus 18 minus 9. This does not give me 0, so x minus 1 is not a factor. So now I'm going to try x plus 1. So I'm going to have f of minus 1. So I'm going to get 2 lots of minus 1 cubed, sorry, these are cubes, plus minus 1 squared, minus 18 lots of minus 1, minus 9. I'm going to get minus 2 plus 1 plus 18 minus 9. Again, this does not equal 0. So now what I could try is I could try x plus 2. So if I try that into the question, I see what happens, x minus 2, you know, I can keep going, okay? And once I try a few, I'm going to find they don't equal 0. So I'm going to try x minus 3. So that means I'm going to try f of 3. So I'm going to get 2 lots of 3 cubed plus 3 squared minus 18 lots of 3 minus 9. This does in fact equal 0. So therefore, x minus 3 is a factor. Now we know that it's a factor, we're going to have no remainder now when we divide. So when we use algebraic division, we're going to have x minus 3 into 2x cubed plus x squared minus 18x minus 9. So how many x is going to 2x cubed? 2x squared. Okay, so remember, I'm a silly Billy. Now we're going to multiply. So 2x squared times x, 2x cubed. 2x squared times minus 3, minus 6x squared. Now we're going to subtract 2x cubed minus 2x cubed is 0. X squared minus 6x squared is 7x squared. And then bring down. Now into x into 7x squared, 7x. Multiply 7x times x, 7x squared. 7x times minus 3, minus 21x. Now I'm going to subtract. Minus 18x minus 21x is positive 3x. I'm now going to bring down. I'm now going to multiply again. How many x's into 3x? The answer is 3. X multiplied by 3 is 3x. 3 multiplied by minus 3 is minus 9. We can see here we get a remainder of 0. So now we know that 2x cubed plus 2x squared minus 18x minus 9 can be rewritten as x minus 3 bracket 2x squared plus 7x plus 3. But the question says to fully factorize, so we haven't quite fully factorized yet because we can factorize this quadratic here. So this is going to equal x minus 3 bracket. Now we're going to have 2x and x. Two numbers that multiply to give me 3 is in fact 3 and 1. And they have to add to give me 7, so I know I need to multiply 3 by 2. And there we have it. We have now fully factorized this expression by using the factor theorem. Then we've divided, and then we've been able to factorize this. So now we have using the factor theorem, and these are a bit more problem solving type questions because we need to find an unknown coefficient. It says that given that 2x plus 1 is a factor of this, determine the value of a. So if 2x plus 1 is a factor, we know then that x equals minus a half. So to find our value of a, we know when we put the function, when we put minus a half into the function, we should get 0 if this is a factor, and it says it is. So that means we're going to have 6 lots of minus a half cubed plus a lots of minus a half squared plus 1 equals 0. Minus a half cubed is minus 1 over 8. 6, so that's 6 lots of minus 1 over 8. Plus a lots of a quarter plus 1 equals 0. 6 lots of minus 1 over 8 is negative 3 over 4 plus a quarter a plus 1 equals 0. So we're going to have a quarter a plus a quarter equals 0. So a quarter a equals negative a quarter. So a equals negative 1. Okay, so all we had to do is use our knowledge of the factor theorem. So what I would like you to do now is to test your understanding. So, can you please use the factor theorem to show that x plus 2 is a factor of this equation and then factorise it completely? And then here we says, given that 3x minus 1 is a factor, determine the value of a. So for part B then, use the factor theorem to show that x plus 2 is a factor. So we want to show that f minus 2 equals 0. So we're going to have 6 lots of minus 2 cubed plus 13 lots of minus 2 minus 4 equals 0. Now it says show that, so we really do need to make sure that we're showing. So minus 2 cubed is negative 8 times 6, which is negative 8 times 6. I can't think off the top of my head. Negative 48. Okay, so negative 48, 4 times 13 is 52, minus 4 equals 0. Therefore, x plus 2 is a factor. Then it says factorise completely, so we are going to be, if I zoom in here, so I'm going to have x plus 2, 6x cubed plus 13x squared. Now remember, plus 0x minus 4. So I'm a silly Billy again. So how many x's into 6x cubed? 6x squared. Multiply 6x cubed plus 12x squared, subtract, I'm left with x, 13x squared minus 12x squared is 1x squared, bring down into x, multiply x squared plus 2x, subtract minus 2x minus 4. So I'm going to have minus 2, and then we should have minus 2x minus 4. That should leave you no remainder. So now you know that we can rewrite 6x cubed plus 13x squared minus 4 as x plus 2, 6x squared plus x minus 2. So I now need to factorise 6x squared plus x minus 2. Now with 6x we could either have 6 and 1 or we could have 2 and 3. Now I'm going to go for 3x and 2x. Two numbers that multiply to give me minus 2 is minus 2 and 1 or 2 and minus 1. So now I need to figure out I want a positive x. So if I want x, I'm thinking I need 4 minus 3. So I need, this one's going to be my positive 2, and then I've got plus 2 minus 1, and that's going to give me 4 minus 3. Again, when in doubt, work it out. You can double check that. You can expand these two, and you know, this is something either use the AC method or use your calculator for, but we should, you know, this is not a skill I'm going to go over in these PowerPoints. So there you go, we have fully factorised this. Any questions? It then says, given that 3x minus 1 is a factor, so that means 3x minus 1 is a factor, that means x equals a third, because that's what makes this bracket 0. So that means if we substitute into the function a third, it will equal 0. So we're going to have 3 lots of a third cubed plus 11 lots of a third squared plus a lots of a third plus 1 equals 0. So 1 over 27 times 3 is 1 over 9. 1 over 9 times 11 is 11 over 9. plus a over 3 plus 1 equals 0. So I have 12 over 9 plus 1, which is 21 over 9. So minus 21 over 9 if I bring it to the other side. And again, I'm just doing simple rearrangement here. And then if I multiply both sides by 3, I get a equals negative 21 over 3. We know that negative 21 divided by 3 is in fact negative 7. So in this case, our a is negative 7. Just going back to part A as well, just so you know, when it says on part A, use the remainder theorem to find the remainder when f of x is divided by 2x plus 3, all you need to do is substitute in x equals minus 3 over 2 into the equation, and then you will find the remainder. So the second section of this chapter is proof. So there is a few different words that we need to learn. Conjecture is a mathematical statement that has yet to be proven. And a theorem is a mathematical statement that has been proven. Okay? So we've got types of proof. Type 1. Proof by deduction. This is the simplest type, and you start with the facts and then you get to a conclusion. So prove that the product of two odd numbers is odd. Okay, so first of all, what is an odd number? So an odd number is 2n plus 1. And it says prove that the product of two odd numbers. So we know we need to multiply 2n plus 1 times 2n plus 1. Now, ultimately, our number needs to be a multiple. It needs to be one more than a multiple of 2. That's what this is. So when we expand this, I'm going to get 4n squared plus 4n plus 1. Now, I need to make sure I put it into the form 2n plus 1. Now, in our case, I'm going to have 2n, lots of 2n plus 2 plus 1. This is still in the form 2n plus 1. Oh, actually, you could have left the n in here. So sorry, everyone. 2 lots of 2n squared plus 2n plus 1. Now this is in the form 2 lots of a number plus 1, which we know is odd. Therefore, odd. And then the second type of proof is, as we've seen this before, these are identities. You've got to prove that this multiplied equals this. Now, what we like to do with these types of proof is say left-hand side equals 3x plus 2, x minus 5, x plus 7. And then we keep going. So if I expand the first two brackets, 3x times 5, 3x squared. 2 times minus 10 at 5 is minus 10. 2 times x is 2. 3x times minus 5 is minus 15 plus 2, minus 13x, multiplied by x plus 7. So I'm now going to multiply everything by x. 3x cubed minus 13x squared minus 10x. I'm now going to multiply everything by 7. 21x squared. 13 times 7, anybody? 49, 56, 63, 70, 77, 84, 91. Minus 91x minus 70. That equals 3x cubed minus 13x squared plus 27x is, I don't know off the top of my head. It's going to be, oh, I don't get 8x squared though. I get 14x squared. Have I gone wrong somewhere? What? Oh, everyone, you didn't tell me 7 times 3 is 21. That makes sense. So then that means I have 8x squared minus 10 minus 91 is minus 101x minus 70. Now this equals the right-hand side, which here is my right-hand side. That was what I was trying to prove. Therefore, proved. So, nice and simple examples here. So, proof by deduction requires you to start from known facts and end up at a conclusion. You cannot start with a conclusion and then say that you've proved it. So, prove that if three consecutive integers are the sides of a right angled triangle, they must be 3, 4, 5. So what we cannot do is this. Now, I have to actually look at the answers for this because I don't know what we can't do. I'm assuming we can't start with, yeah. So we can't start with 3, 4, 5. So we can't say 3 squared plus 4 squared equals 5 squared. 25 equals 25, therefore proved. Okay, this is wrong. No, 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 no. We cannot do that. We have to start with what we know, okay? So we know that 3, 4, 5 are 3 consecutive numbers. So in this case, what do I have? I have x plus 1, and x plus 2. This is 3 consecutive numbers. We don't know if we're starting with odd or even. So what we can say is, we know that Pythagoras theorem states that a squared plus b squared equals c squared. Okay, this is a known fact. 3 consecutive numbers. So we know then that x squared plus x plus 1 squared equals x plus 2 squared. So if I expand this out, I'm going to have x squared plus 2x plus 1 equals x squared plus 4x plus 4. If I move everything to the left-hand side, I'm going to have x squared minus 2x minus 3 equals 0. If I factorise this, I'm going to get x minus 3 and x plus 1 equals 0. Okay, so that means x equals 3 and x equals minus 1. We reject minus 1 because we cannot have a negative length. So therefore, x equals 3. So if you go back to this is 3, this is 4, this is 5. Okay, so therefore, 3, 4, 5, therefore, proved. So we've now proved that, but we've proved it using known facts, using known theorems, Pythagoras theorem. So then, we have another type of proof, the proof by deduction. So we've got to prove that this is positive for all values of x. Now, as we know, to prove something is positive, we need to show a square number. So what we are going to do is complete the square. So x squared plus 4x plus 5 can be rewritten as x plus 2 all squared minus 2 all squared plus 5. which we know is x plus 2 squared minus 4 plus 5 is plus 1. We need to prove that this is greater than 0. Okay? Now, what do we know? We know that x plus 2 squared is greater than or equal to 0 for all of x. Why? Because this is a square number. Therefore, we know that x plus 2 squared plus 1 must be greater than or equal to 1, which we know is greater than 0. Therefore, x plus 2 squared plus 1 is greater than 0. Proved. So what I want you to do now is I want you to test your understanding. I'm going to give you a second so that you can test your understanding. Off you go. Okay, so prove that the sum of the squares of two consecutive odd numbers. So we know an odd number is 2n plus 1. And then the next odd number is 2n plus 3. You could have used, if you wanted, 2n plus 1 and 2n minus 1. So it proves that the sum, so if it's a sum, we're adding. So 2n plus 1 plus 2n plus 3 equals 4n plus 4. Oh, I've gone wrong already. Sum of square numbers, so I need to square them and then add them. Okay. So we're going to get 4n squared plus 4n plus 1 plus 4n squared plus 2 times 6, 12n plus 9. This is going to equal 8n squared plus 16n plus 10. And it says is 2 more than a multiple of 8. So I need to factorise out 8. And if I factorise out 8, I'm going to get n squared. Now, before actually I factorise out 8, I want to factorise out 8, but you see I can't factorise out 8 out of 10, but we can split this up. 10 can be rewritten as 8 plus 2. So what I'm actually only going to do is factorise this part here. So I'm going to have 8 lots of n squared plus 2n plus 1. This is a multiple of 8. And then plus 2. So here you can see 8 is a factor. Therefore, multiple of 8. And then here we have 2 more. Therefore, proved. Okay, it's really important that we have these proofs written like this so that, you know, the examiner knows, you know, and we're laying it out in a very simple way. So, here are some questions. As we all know, when in doubt, draw it out. So we're going to prove 14. Now, even though with a proof you do not need the drawing, it's really good that we understand what's going on. So prove that these vertices are the vertices of a right-angled triangle. Okay? So first of all, what do I need to do? I'm going to just draw them. So A, just to get an idea of what's going on. A is 3, 1, roughly here. B is 1, 2, roughly here. And C is 2, 4, roughly here. Okay, so we need to prove that these are the vertices of a right-angled triangle. Now, can someone tell me what facts do we know about right-angled triangles? Absolutely, Guida. They have a right angle. Okay? Right angle triangles have a right angle. Okay, so if they have a right angle, what does that mean? We could use Pythagoras. What else could we use? What do we know about right angles? Yeah, so two lines meet. The lines are actually what we call perpendicular. Absolutely. So the gradient of 1 multiplied by the gradient of 2 should equal -1 if they are perpendicular. So what we're going to do, let's try and see if we can find a perpendicular. So if we did the gradient of AB, we get 1 minus 2 over 3 minus 1. 1 minus 2 is -1 over 2. If, okay, so the gradient of AB is -1 over 2. Realistically, I think if anywhere, the right angle is going to be here. So now I want to do the gradient of BC, but it might not work like that. Gradient of BC, 5 minus 2 over, is it 5 minus 2, yeah? No, that's supposed to be a 4, everybody. 4 minus 2 over 2 minus 1 equals 2. So does -1/2 times 2 equal -1? Yes, they do. Therefore, AB is perpendicular to AC. Therefore, right-angled triangle. So you can see how we've used our knowledge. Now, in terms of using Pythagoras, we could use Pythagoras, but if you think about it, it's going to be a lot longer, because we'd have to use Pythagoras here to find this length, then Pythagoras here to find this length, Pythagoras here to find this length, and then show that this squared plus this squared equals this squared, which would actually take a lot longer. Okay, so we can do that, but it would take longer. So we want to find the quickest way to prove it. So, other types of proof. We know we have proof by exhaustion, and we have proof by counterexample. So, prove that n squared plus n is even for all integers n. Now this one we're proving everything. So we know that n is either even or odd. Now the proof in the book uses words, but you know, I really think that we shouldn't just use words. We use algebra. So if n is even, we know that this is 2n. So therefore, 2n squared plus 2n, which equals 4n squared plus 2n, which we know we can factor out a 2, and we get 2n squared plus 2, which we know is even, because it's in the form 2n. If n is odd, we know an odd number, 2n plus 1. So therefore, we're going to have 2n plus 1 all squared plus 2n plus 1, which is going to equal 4n squared plus 4n plus 1 plus 2n plus 2, which equals 4n squared plus 6n plus 3. Is that right? No, that's not right. I didn't I? So this is now plus 2. Now remember, if it's even, we can take a factor of 2. So we've got 2n squared plus 3n plus 1. This is still 2n. So this is also even, okay? Therefore, n squared plus n is even for all integers of n. So we've proved every case. Then disproof by counterexample. It says disprove the statement n squared minus n plus 41 n squared minus n plus 41 is prime for all integers of n. Now, what are we going to do? So we need to find a number for when this isn't true. So for example, let's try n equals 2. 2 squared minus 2 plus 41 equals 43, which we know is prime. Okay, so that one doesn't work. Let's try n equals 3. 3 squared minus 3 plus 41 equals, so we get 9 minus 3 is 6, get 47. Okay, that doesn't work. We're going to try n equals 4. 4 squared minus 4 plus 41 equals 53. Okay, so I've tried a few and they don't work. Sometimes it's good to try the number that you have. So they've given us 41, so let's just try n equals 41. So 41 squared minus 41 plus 41. Well, this equals 41 squared. Now, I could figure that out, but actually, hold on a minute. Whatever that value is, 41 is actually a factor. So it cannot be prime, because prime numbers have exactly 2 factors, the number itself and 1. Therefore, not prime for all integers of n.